gonna just record this video for Campbell because he wanted to have, looks like wanted to have 1000 with a permutation of 1000. Actually population, I hope you understand me because I'm very tired and I just don't know what I'm talking about. It's I'm gonna run with 1000 permutation per population. As I explained before, in the here, maybe I can explain a little bit better if I have more concentration. I say instead of random generating population, it's better to have the random imaginary points. I can make it even simpler. Imagine we calculate every color. Let me just go for the imagine we calculate every color with the this one here. That means if we have a one color RGB here, we're gonna calculate the distance and sort it this one. Every color we make a distance between every color everywhere in the 3 dimension. We calculate the distance, and that's gonna be the, are we gonna sort it later? That's going to be our first starting genetic algorithm, and because it's going to be good point, usually going to be about 300 something. But if you have a more for population, more points, you can calculate every color is in. You see that this one is the color, and I can calculate that distance every color with this point as well. And that's this. Imagine this is the point. I can just create many imaginary point to create a different population. Is about population here with this way is makes sense and give you better answer instead of a random. Okay, I'm gonna run this program for, and let's see how long does it take for the 1000. And as soon as I run it, the first my program goes to create different random point and calculation distance all the colors to that imaginary point, and from that point is 1000 population means for my program means 1000 imaginary point, and distance the calculation all the distance to that points. The reason it's, imagine we have 1000 people in the university, in the atrium, and if you want to see who is the closest to each other, actually the people is gonna be 2 dimension. But the reason I'm calculating different point, okay, the first one comes out, as you can see, the first one is 312, and very quickly goes to 100 and 95, 94, 92, 91, and if I just run my Python program, because I'm writing that information to the file and I don't know how to plot. Let's plot in 73 in Java, and just I wanted to practice Java, that's why I write it. It's a 72, and this is the if I in 1000, in 10,000 it goes much better than this one, and very faster, and it goes even less than that. But for 10,000 is it takes 10 minutes time to calculate make the 10,000 imaginary point and calculation all distance between the 1000 colors to that points. That is the 10 minutes, but after 10 minutes it takes very quickly. As you can see, I just put the timer start as 9:56, and I didn't calculate for creating that point. Is, as you can see, in 1 second, 2 seconds, it goes from 94, from 312 is 956, 10, 956, 10, and this one is 956, 10. In 1 second is jumped from 312 to 240. The reason again, I've just okay, come to the 68, and I'm gonna just show you what is going to be the color. And in the program is calculate again the Euclidean distance is 68, and our output is going to be like that. I'm still not happy with that, but for the next, I'm gonna upgrade my program to here. I think I don't know how to. Let me print a screen. For the next time, I'm gonna add a little bit more for optimization. I'm gonna do. Okay, no, I don't want to save drive, and I explain it here to not bothering you anymore. Okay, just let's close it and just again Alt print screen, and no thanks, and Control 3, and this is I'm just here, Alt print the screen, and here I'm gonna say yes. For the next time, I'm gonna you know, here in the programming, I just wanted to share you this idea as well, and in the programming I'm gonna bring this one separately in the finding, actually the jump, because between these two colors is very jump, but they are come together. I'm just gonna, for example, take this one too and put it here, and I can find it by programming. As you can see, they become together, and I'm gonna, for example, this one as well, because I think optimization is random, doesn't help is that much. You have to bring that one, and for example this one as well. This can be possible by programming instead of the, okay, this one as well, and for example this one here for the making the because you can from distance you can everything. The best solution, you can see there is a distance between colors. For example, here let me show you. Here you have a, like all the red come together, suddenly goes to the green. You can pick that point for using the crossover. If you, instead of having these points can be very good for the that means you breaking down your array, your sorted your data on this point. For the next version I'm gonna do that, and for the crossover to point, I'm gonna break my array in two parts, one part getting from father and mother, and I'm gonna use that jump between the colors, because I can easily find out there is the calculate this point in my array. That is the jump is the most important, and make it very easier to, because if we guide crossover in this way, we're gonna get very better answer. I hope this video is gonna help who wants to make it better, have a better color. Okay, thank you very much. Definitely I'm going to sleep. I'm trying. Bye for now.